Hello and welcome to the GCSE Chemistry tutorial for topic C1, Atomic Structure in the Periodic Table. This tutorial will cover groups in the periodic table. Let's just recap the periodic table. Groups are vertical columns that go downwards. You will need to know about group 1, group 7, group 0, and the section in the middle here called transition metals. Starting with group 1, these are called alkali metals. They include lithium, sodium, potassium, rubidium, cesium and francium. Group 1 metals get more reactive as you go down the group. They're all soft metals, in fact you can cut them with a knife, and they're stored in oil and have a low density. If you look at the diagram, you can see from their electronic structure they all have one electron in their outer shell. That means they're in group 1 as well. Because they have one electron in their outer shell, that also means that they're very reactive. Remember, elements want to get a full outer shell, so if they lose that one electron, they will then become full. So why do they get more reactive as you go down the group? Well, the further you go down the group, the bigger the atom, and the further the outer electron is from the nucleus. Now there is a force of attraction between the negative electron and the positive nucleus. The bigger the atom, the further the outer electron is from the attraction of the nucleus. So there's less attraction, so it's more easily lost and more reactive, which means that potassium is more reactive than lithium. Other points to note is the melting and boiling point decreases as you go down the group, and also the mass number increases. Group 1 metals lose one electron to form positive ions when they bond, and they bond during ionic bonding, so we can look at that in the next topic. When alkali metals react with water, they produce hydroxides and hydrogen gas. Look at the example below. When you put lithium into water, it fizzes slowly on the surface and floats. Sodium is a more vigorous reaction and it turns into a ball. Potassium is even more vigorous and it gives out a lilac flame. The other elements from group 1 you won't have seen in the classroom, but they will be even more vigorous reactions. When alkali metals react with oxygen, they form metal oxides. When alkali metals react with chlorine, they form metal chlorides. Moving on to the halogens. Halogens are group 7. So you've got fluorine, chlorine, bromine, iodine. All halogens have 7 electrons in their outer shell. Fluorine is a poisonous yellow gas. Chlorine is a poisonous green gas. Bromine is a dense red-brown dangerous liquid. And iodine is a grey-purple solid at room temperature. As you go down the group, they become less reactive. And that's because this time they're trying to gain electrons to become full. So the larger the atom, the harder it is to gain another electron. So fluorine is the most reactive because it easily gains one because the outer shell is closest to the nucleus. Also, as you go down the group, the melting and boiling point increases, as you can see from the graph. Halogens exist as diatomic models, which means they exist in pairs. So like Cl2 means 2 chlorine atoms joined together. When they react, they do so to get a full outer shell, and that can be ionic bonding, where they gain an electron to form a negative ion, or they share electrons in covalent bonding. We can look at bonding in another tutorial. Halogens also carry out displacement reactions. A more reactive halogen will displace or take the place of a less reactive halogen. Let's look at this example. When you add chlorine to potassium bromide, because chlorine is more reactive than bromine, it will displace it and become potassium chloride and leave bromine behind. In this case, you will see a colour change as shown here. If you pause the tutorial and try and answer these questions. Sodium and water make sodium hydroxide and hydrogen. Chlorine and potassium iodide, that's a displacement reaction. So because chlorine is more reactive than iodine, it becomes potassium chloride and iodide. In the last equation, because bromine is not more reactive than chlorine, it can't displace it, so there's no reaction. Moving on to the noble gases, these are in group 0 and include helium, neon, argon. They're all unreactive or inert, and that's because they have a full outer shell. They don't need to lose electrons or gain them or share them. They are full, so they don't react. They're not flammable, they're colourless gases, and as you go down the group, the boiling point increases, as shown on this graph. And that's because there's more electrons, and so more forces need to be broken. 6-mark question to describe and explain the reactivity of group 1 alkali metals. If you pause and give yourself 10 minutes. So, first of all, you need to say that group 1 metals get more reactive as you go down the group. You can then give some examples of this. So lithium, when you put it in water, fizzes and floats, whereas potassium reacts more violently and gives out a lilac flame. So why? You need to talk about the electronic structure. So all alkali metals have one electron in their outer shell, which they lose when they react. The bigger the atom, the further the outer electron is from the nucleus. That means it has a weaker attraction to the nucleus and is more easily lost. So for this reason, as you go down the group, the bigger the atom, the easier it is for the outer electron to be lost, so the more reactive it is. You might also want to draw diagrams to show lithium and then potassium to show that this potassium atom would be more reactive because the outer electron is more easily lost because it's further from the central nucleus, whereas this one isn't. So in summary, we've looked at groups in the periodic table, group 1, group 7 and group 0.